Welcome to the project demonstration of defogging device. So in this project mainly we are using two major components. One is rain sensor to detect the rain, and humidity and temperature purpose we are using DHT11 sensor. So these two are the main inputs in our microcontrollers, the Arduino UNO board we are using. So whenever the rain detects, a UNO board will trigger this electromagnetic relay to control the power supply to this Peltier system. So we are using this Peltier plate along with cooling fan. So this heat sink is for the heating dissipation purpose, and this one is the cooling end. So when the relay getting switched on, the power supply will be given as input to the cooling fan as well as Peltier plates. So this Peltier side will getting cooled down. At the same time, the so-called temperature was difference will be dissipated to the heat side, and that will be sent outside with the help of this exhaust fan. So when we are placing this to this chamber, so we will mount this cool side inside this chamber, and we enclose that, and output is going to be the exhaust will be given to the another external chamber. In that we are continuously monitor the humidity, and whenever the heating was appearing into this system, then the humidity will be comes down, and whenever the humidity increases due to the rain, then that will be come down by this dissipation of heat air into this external chamber. So the rain detection will be done by the rain sensor, and continuously humidity and temperature monitored into the ThingSpeak cloud platform for every 15 seconds of duration. So we'll log this, and from there we came to know the humidity difference whenever we are sending this heat dissipation air to the external chamber. So here the power flow is, we are providing 230 volts AC input to the transformer, so which will step down the 230 volts AC to 12 volts of AC, and that will be converted into DC with the help of this KBL10 rectifier IC, so which will provide the DC, and there will get the 12 volts DC, that is 12 volts DC input to the UNO board, and we are going to regulate that to 9 volts in order to protect the Peltier plate. So the Peltier plate working voltage is actually 12 volts, but if we provide that, there may be chances of Peltier plate may get damage. So in order to prevent that, we are regulating that to 9 volts DC with the help of this LM2596 voltage regulator. So the output 9 volts DC is input to the fan Peltier plate through this electromagnetic relay, which will acting as a switch in between the supply and the load. So this relay will get triggered from the UNO board. Coming to the interfacing connections, so we have interfaced the rain sensor at A0, 12th pin for this relay, and 10th pin for the DHT11 sensor, and 8 and 9 for the ESP8266 Wi-Fi module, which is used to send the data to the ThingSpeak cloud platform. So let us see the demonstration. So let me tell one more time. Transformer step down, rectifier to convert AC to DC, LM2596 voltage regulator to regulate the 12 volts DC to 9 volts DC, electromagnetic relay to switching purpose, and this one is a rain sensor amplifier, and this one is a rain sensor, and ESP8266 Wi-Fi module with the driver board, and DHT11, and interface to the UNO board. So before on the power supply to the kit, first of all we need to enable the hotspot in your phone. So using that hotspot only, the system will upload the data to the ThingSpeak. So for that, go to hotspot settings and configure the hotspot to project 6199 without any space, without any capital letter. Password should be 123456789. AP band should be 2.4 GHz. After these three settings successfully done on the hotspot, and log into the ThingSpeak cloud platform, now you can on the power supply to the kit. Right, so on the power supply to that, there we can see the one device is connected in your mobile phone. Right, so after that, wait for 15 seconds of duration. You can see the live data will be uploaded into that. As a ThingSpeak, accept the data for every 15 seconds duration only, and it will be stored until you clear the channel. Right, mobile data should be on. Right, we got the new data. This is a previous data, and we got the live data. So when you click on that, we can see the date and time along with the sensor details. The humidity 64%, and temperature in temperature in 28 degrees centigrade. And after that, if you want to clear the channel, so better import the data before clearing the channel. For that purpose, go to data import export option, and in that download the data. They can download the data in Excel sheet, and we can open that, and there we can see the data in column wise, and the first column is date and time, and how many samples till now we have collected, and the field 1 is the humidity, field 2 is the temperature. So after this confirmation, now you can erase the data. For that, go to channel settings, and in that don't do any other changes, directly go to clear channel. Don't delete channel, only clear channel. Right, on successful channel clearing, now go to private view. Private view to see the live data, channel settings to clear the channel, and data import export to download the data. Now the old data got erased. Right, so now wait around 15 seconds duration to get the live data again. So meanwhile, provide the input to the rain sensor. When we provide the input to the rain sensor, right, there we can see the light in two light indication on this system. Right, so as we have done some changes due to the power fluctuations, we have provided the another external power supply for this Arduino UNO board, and power supply for our only Peltier bed system, as the Peltier bed consists like it consume the more power. So as of now we can see the rain detects, the relay will get switched on. As we can see, the fan also is running inside that, and whenever the rain is normal, there you can see another light switched off on the sensor, and relay will get switched off, and we can see the Peltier bed also getting switched off. Right, so we got the live data again now.